Hello everyone! I'm so excited to share a sneak peek into how we are making abstract CS concept tangible and engaging for all our students here at Cobie AI. The challenge of teaching computer science, especially networking, is making those bits, binary, and hex code real for students. It's so abstract, I'm always asking myself, how do I make this click? That's where our new addition to the Network Lab truly shines. The key part of that is the incredible LED display. We've introduced this display to show students how binary numbers can light up LED lights on display, making the invisible visible. Students can control the whole display, a column of lights, or even a single light. Now, I will switch to the projector view and let the Cobie AI explain everything about the assignment at hand.
To control the lights on the display, we have three different versions of the lights command. The first is a simple command to turn all the lights on or off at once. The next is the so-called bit command, or a sequence of bits. With the bit command, we specify which columns of the display, that is, which columns of lights, should be turned on using a combination of bits, 0 for an off column and 1 for an on column. The final and most precise option is using the HEX command. With this command, we use hexadecimal notation to precisely determine which lights are on. This allows us to turn on individual LEDs. Your first task will be to turn on all the lights using the simple command, lights on off. This will let us see how the LED display works. Are you ready? Don't worry, we'll wait for you.
Let me show you how this looks for a student. We will light the whole LED to start. We are now looking at this from a student's perspective. This is how the student sees the network lab. Student has a panel to send commands. Student sees the packets that were sent and packets that were received. When a student interacts with a device, the display will also appear in the list of devices. So, let's send a command to turn on all the lights. Great, isn't it? Before we move on, let me show you how this looks from the teacher's perspective. Now we are watching the teacher's screen and I, as a student, will turn on the lights. The teacher will see which device I'm sending the commands to and what those commands are. Also, the teacher will be notified if a student has successfully completed the assignment. I will move to the student's screen now. Next, let's light up every second light on the display. This uses lights command, but with 32 bits. Each bit controls a column. This way, students are learning about the importance of bits and their positions. So, for example, let's turn on the third column. And the lights are lit. Now let's turn on every second column. This is where you will hear that silence in the classroom, mixed with sighs of satisfaction, making them aware of their control. For the last example I want to show you, let's see how students can control a single light. Let's turn on the bottom left light. This way, students learn how to control a single bit or light, understanding that each column is composed of two hexadecimal numbers and that the bit mapping is inverted. For example, a value of 8 will turn on the top light, while 1 will turn on the bottom light. And now let's go for a flashy demonstration. I will write a whole word on the screen. Cobie, of course. For this part of the Smart Classroom, we have also prepared assignments that you and students can use, where they practice the conversion from bits to commands, from hex to binary. You will see as they transition from not knowing how to grasp the conversions to going to the phase where they are in control. And the chatter will start. They will communicate with each other to get the best results. That's it for this demonstration. Please contact us if you have any questions or you need a further explanation how we can fit this into your classroom, or if you just need a complete demo of our features. Also, please like and subscribe. Bye.